Today's target will be exponent rules. By the end of today's lesson, you will be able to use the multiplication, division, and power rule of exponents to simplify problems with exponents. Before we jump into that, just a prerequisite when it comes to variables and exponents. Keep in mind what you learned in pre-algebra. That is, when you're adding and subtracting, you can only combine similar variables with the same exponent. So for example, I can add x squared plus x squared, and I have two of them, so I would write 2x squared. Or I could add 3y plus 4y, and I would have 7 of them, so I would have 7y. I cannot take x squared and add y to it. It cannot be simplified because they're not like terms. Just a little prerequisite knowledge, keep in mind. Everything we do today, though, will be with multiplying, dividing, and power rules. Just a couple vocabulary terms. First off, this 5 is what we call a coefficient. The x is called a base, since it is being raised to an exponent. So if you hear me refer to things like coefficients, bases, and exponents, these refer back to this page, and this is what I'm talking about. So let's start with the multiplication rule. That says when you are multiplying like bases, you add the exponents. So a to the third power times a to the second power would be a to the fifth power. The reason this works is that a to the third power is telling us that we are multiplying a by itself 3 times. A to the second power tells us we're multiplying a by itself 2 times. So altogether, we have 5 a's, a to the fifth power. Here's an example. 3x squared times 5x to the third. First thing we're going to look at are these. These are our coefficients. The exponent rules don't apply to these guys. This is simple multiplication. 3 times 5 is 15. When I look at my variables, I have like bases. They're both base x. So I can take the exponents, x to the second times x to the third. I have a total of 5 x's being multiplied together, so I would have x to the fifth power. Next up is our division rule. That says when you are dividing like bases, you subtract the exponent. More specifically, you take the exponent of the numerator minus the exponent of the denominator. So if you had a to the seventh over a to the fourth, you would take the top exponent, the 7, subtract 4, and you would end up with a to the 7 minus 4, which would give you a to the third power. The reason this works is you have 7 a's on top being multiplied together, 4 a's on the bottom. We can cancel out, and we're left with 3 a's. This one can be a little bit tricky, because if this is flipped, you had, let's say we had the smaller exponent on the bottom. We had a to the third over a to the fifth. Now, if we were to write this out, we would have 3 a's on top with 5 a's on the bottom. So when we cancel out, we're left with 2 a's, but they're on the bottom of the fraction. So they have to stay on the bottom of the fraction, and we would have to put a 1 at the top. So if the bigger exponent's in the denominator, the variable stays in the denominator. So be very careful with that. Pay attention to where the bigger variable is. Let's look at an example. Once again, we're going to start with our coefficients, 8 and 4. The exponent rules don't apply to these guys. We do simple division here. 8 divided by 4 is 2. I'm going to go ahead and give myself a fraction bar. I'm looking at my x's here, and I notice that I've got a bigger exponent on the bottom. So when I subtract, the difference between 3 and 5 is 2. Because the bigger exponent's in the denominator, that x squared has to stay in the denominator. But with my y's, I've got y to the 6th and y squared. The bigger exponent's in the numerator, so the y stays in the numerator. 6 minus 2 gives me y to the 4th, and it's going to stay on top because the bigger exponent was on top. Our third rule for today is the power rule. When you have two exponents applied to the same base, you multiply the exponents. So this might look something like this. X to the third raised to the 4th power. So when you have this, you would do x to the 30 times 4, which would give you x to the 12th power. This breaks down as such. If we have x to the third in parentheses raised to the 4th power, it means we're multiplying x to the third 4 times. We can see here, using our multiplication rule that we talked about at the beginning of the video, that we're multiplying the same base together so we can add the exponents. So this would be x to the 3 plus 3 plus 3 plus 3, which once again gives us x to the 12th. Because ultimately what we have here is 12x's being multiplied together. Thought I had an example there. Apparently I had to come up with one on my own. So here we have 3x to the 4th power in parentheses raised to the 2nd power. When you have an exponent here, you have to treat it kind of like you do when you're distributing. That 2 gets applied to both the x to the 4th power and to the 3. So what we're going to do here is we're going to break this up, and we're going to have 3 to the 4th power and x. Sorry about that. That's not correct. I'm distributing the 2nd power. So it would be 3 to the 2nd power, and then x to the 4th also to the 2nd power. 3 squared gives us 9. Here we've got two exponents on the same base, so I'd have x to the 4 times 2, which would give me 9x to the 8th power. Okay, those are your 3 rules. It is now time for you to try a couple. You've got a multiplication rule in number 1, a division rule in number 2, and a power rule in number 3. Go ahead and pause the video now. Give them a shot. Here at number 1, we've got multiplication. Start with your coefficients. Multiply them together. 6 and 2 gives you 12. You have like bases, x to the 4th, x to the 7th. Multiplying like bases tells you to add them together. 7 and 4 gives you x to the 11th power. And number 2, start with your coefficients again. 12 divided by 3 gave us 4. Then we look at our x's. The bigger exponent's on the top. So we do 8 minus 3 to give us x to the 5th, and that x stays on the top. With our y's, however, the bigger exponent was on the bottom. So the difference between 7 and 3 is 4. So we have 4 y's left over, and those have to stay in the denominator because the bigger exponent was in the denominator. Number 3, we've got a power rule, so we're going to distribute this exponent of 2 to both our 5 and our x to the 6th power. So we have 5 squared, which gives us 25. 2 exponents on our x, so we end up with x to the 6 times 2, which gives us 25 x to the 12th. If you had any questions or comments or concerns with the video, make sure you make a note of them, and you can bring them with you to class to get those questions answered.